Hello students, today our topic is electric dipole. Electric dipole means when two equal and opposite charges separated by a small distance, then it is known as electric dipole. Now, so this is, let us suppose that the equal charges which are minus q and plus q. These are the equal and opposite charges placed at very small distance. Then it will becomes an electric dipole. Let us suppose its a distance between minus q and plus q is twice a. So now we define it to equal. The definitions of the electric dipole is two equal and opposite charge opposite charges placed at a very small distance. Then it is known as electric dipole. An electric dipole so here let us suppose minus q is placed at the point of A and plus q at the point of B. So AB is here, length of the dipole is equal twice A, since it is a vector quantity. Now the vectors will be in vector format. We can write this one. Now its directions will be from minus q to plus q. Direction of twice A is from minus q to plus q. So these are definitions. Electric means because the charge is the electric. Now next topic we have dipole moment. Dipole moment, electric dipole moment. Now electric dipole moment. So it is the product of the either charges and the distance between the charges. So known as electric dipole. The product of either charges, either charge and distance between them. This distance between the equal and opposite charges is known as electric dipole. Electric dipole and moment. Now it is a vector quantity. It is a vector quantity. We represent it. Vector with dipole moment is equal to either charges q multiplications vector twice A. So this is the vector quantity and its directions will be from minus q, as the direction of vector twice is from minus q to plus q. Now the directions of dipole moment is obviously direction of dipole moment is from minus q to plus q. So now this will be the directions. Now about the this is a vector quantity. Now it's a unit. Unit will be coulomb multiplied meter. SI unit known as SI unit. SI unit of electric dipole will be coulomb multiplied meter. So this is about the electric dipole moment. So there are many axial molecules. They are dipoles like water and ammonia. Nature has many dipole moment. Now the example is water molecules and ammonia. There are many other. Ammonia are dipoles. So what about dipole of water and ammonia? It means that if the center of gravity of positive charge of water, positive charge and negative charge of water and ammonia are separated very small distance, then it will becomes a dipoles. So that's why according to definitions, when two equal and opposite charges, same way here in water and ammonia, they have equal positive and negative charges. If they are separated by a very small distance, then it will becomes dipoles. So there are many other molecules which are not dipoles, and some are dipoles. Now in this article, sir, we have to find out electric dipoles at an axial point. So for the electric dipoles, so we have to find out at three places: at axial point, and at equatorial point, and at some angles with the axial line. So this is our electric dipoles. Let us suppose at the point of P, minus q charge is placed at the minus q is here, and plus q हम place कर देते हैं at the point of B point में, and वो आपके पास वो is the midpoint of A and B. Let us suppose P is the point where we have to find out the electric field due to these system of electric charges. So the distance from O to, let us suppose the distance from O to P is R. Now let us suppose this is the distance from O to P, and the distance between minus q and plus q is too small a, and therefore O is the midpoint. This will be A and this will be also A. Now this is A from here to here, and this is again A. So there this is the systems, and from A to B is known as the dipole axes. So AB, vector AB will be twice A and a dipole axis. So this is our system. Now this is plus q. Plus q has the electric fields away from this ones. Now we represent it by EB, vector EB. Vector EB the electric field which is produced by the charge placed at the point of B, and this is minus q charges. It also produces an electric field. Its directions will be along these ones. So now we have represented by the vectors of EA. So this is the electric field produced due to minus q charge placed at this one. Since both are the vector, the resultant electric fields at the point of P will be, resultant field will be resultant electric fields at the point P will be vector C is equal to sum of vector sum, not algebraical sum. It will be the vector sum. So now vector EA plus EB. Now the field due to the charge which placed at the point of B is vector EB. We need only just a magnitude. So 1 upon 4 pi epsilon naught charge at the point of B, which is Q, and distance will be from OP, from not OP. This is BP. BP. Now putting the value of BP. BP OP minus OB. It means that R minus A square of this also. Now its direction is along BP. And next one, electric field which is produced by minus Q. So this is the magnitude of this one, will be 1 upon 4 pi epsilon naught. Don't put the charge here with the signs, only put the magnitude of the charge, which is Q, and distance will be AP. AP is the distance. AP, square of AP. Now square of AP will be, this is R and plus A. This is A and this is R. Adding both of these. So 1 upon 4 pi, 1 upon 4 pi epsilon naught Q divided by R plus A whole square. Now its directions will be from P to A. Along P to A. So from the expressions of this and this, so we need, because they are linear along the same straight lines but opposite directions, and the resultant will be along the direction of EB, because the denominators of EB is smaller than that of this one. So our resultant magnitude, resultant field will be here. Resultant field will be EB, since magnitude of EB is greater than that of EA, because the denominator of this EB is smaller than that of EA. So that's why the resultant will be EB minus EA. So this will be the resultant magnetic fields will be along the dipole axis. Yeah, dipole axis. Now putting the value here. Now the resultant field will be EB minus EA. EB minus EA, placing all these value 1 upon 4 pi epsilon naught, and Q is the charges divided by R minus A whole square minus 1 upon 4 pi epsilon naught, and epsilon naught is the electrical permittivity divided by R plus A whole square. Now taking the common thing, which is Q upon 4 pi epsilon naught, if I taken out, the inside of this will be 1 upon R minus A whole square minus 1 upon R plus A whole square. So now again taking the LCM, now it becomes Q upon 4 pi epsilon naught. LCM will be R minus A square times R plus A square, R minus A whole square times R plus A whole square, and goes close this bracket, and this goes this side and this goes this side. Now it will be R plus A whole square minus R minus A whole square. This is the expression. Now after simplification it will be, now the resultant field become q divided by 4 pi epsilon naught, q upon 4 pi epsilon naught. If you simplify it in the numerator, it is r square plus a square plus twice ar, and outside is minus r square plus a square minus twice ar, bracket is closed, and in the denominator we have the denominators, this is a minus b, a plus b. It means that r square minus a square whole square. So we have using this formula, a minus b, a plus b will be a square minus b square. Now close this bracket. Now here, if you remove this bracket, minus r square cancel out, plus a, this will be cancelled, plus twice r minus minus plus become twice ar plus twice ar will be 4ar. Now final expression, so we have therefore q divided by 4 pi epsilon naught 4ar divided by r square minus a square, and it's a whole square. Here is the whole square also. So now next thing is the dipole moment. We know the dipole moment represented by P. It is the either charges. It means that Q times of twice A. So we have place twice A Q in place of twice A Q and P. Now here twice A, taken twice A from here, this value becomes 1 upon 4 pi epsilon naught twice AQ, and remaining is twice R divided by R square minus A square is the whole square. Now final value, so Q not Q, this is a 1 upon 4 pi epsilon naught, and twice AQ replaced by this becomes a 2PR divided by R square minus A square is the whole square. Now this is the final value. So now this is the electric dipole final expression. This one we utilize it when is R not R is not very large than A, but in other case when the R is greater A. Now the case is here. Now if R is greater than A, then we have left A square, then in that case A square will be very small. Now our value of the electric field will be in that case 1 upon 4 pi epsilon naught twice PR in the denominator, and A square I have left, I have not considering here. R square whole square will be R की power 4. Now replace R, cancel to this. Now final expression, so we have 1 upon 4 pi epsilon naught twice P divided by RQ. Now this is this is the restricted case when R greater A. Now its a direction, so it will be from A to P in the directions of along AP. Along AP. Yeah, we also represent it in the direction. So dipole moment has the direction from minus q to plus q, the dipole moment direction. Now in the vector format we can represent it, vector E 1 upon 4 pi epsilon naught, and here 2p vector divided by rq. So now this is the this will be in when r greater a, and in case of this in vector format it will be 1 upon 4 pi epsilon naught, here 2pr, 2p the vector upon divided by r square minus a square. Now this will be the vector expression of this one. This is the magnitudes and the vector formats, and another restricted case will be this one. So now so axis of this one, so dipole axis is a dipole axis is from minus q to plus q. Next topic we will discuss equatorial point. We have to find out the electric field on the equatorial point. This is our system of two charges minus q and plus q, and this is dipole axis, and it will be our equatorial line. Equatorial lines means the line which is a perpendicular bisectors of this line. Now from AB line, O is the midpoint, P and this is at a distance of this is at a distance of P is at a distance of R from O. This is your R, and the distance between minus q and plus q is A. This is A, this is also A. Total distance will be twice A. So now a charge placed at the point of minus q, it will produce electric fields. So direction of the electric fields will be along PQ. Now suppose its value becomes vector EA, because this is negative charges, its direction will be along this ones, and now this is plus q, so direction will be away from this ones. Now the electric field which is produced by plus q will be along this one. This is vector B, vector EB. Now according to Pythagoras, this is R, this is A. Now the distance will be here R square plus A square. This is A and this is also R. Now the distance of PA will be here R square plus A square. Now suppose the angle this is theta, obviously this will be also theta, because this is isosceles triangles. So now the electric field which is produced by minus q and plus q will be in equal in magnitude. Now the magnitude will be in that case electric field due to minus q will be EA, and this is also equal to due to the charges of this ones, because here the magnitude and distance is the same, 4 pi epsilon naught, charge is q divided by this is the distance which is r square a square, square of this one will be, so this is the value. We can also write this now the resultant field will be here. So now this is theta, this is also theta. If I break the component of EB, so EB cos theta will be along this one. Along this one will be EB cos theta. Another component along this one will be EB sin theta. Same way EA is along this one. This is angle theta. Since this line is parallel to this one, obviously this angles will be, this will be also theta. Now it's a component of EA. One is along this one. Along this one will be again EA cos theta. EA cos theta along PX, along x-axis. And another component of EA will be along this one, which is EA sin theta. So EA sin theta component along this ones, and EA cos theta component along this one. So now since EA and EB both are equal in magnitude, therefore EB sin theta, this is EB sin theta, and EB sin theta and EA sin theta will be cancelled out. Only the net electric field becomes EA cos theta plus EB cos. This will be our net electric fields of this dipole axis. Therefore resultant electric field, E the resultant electric field, resultant electric field at P will be EA cos theta plus EB cos theta. So since EA and EB both are equal in magnitude, we take this is twice of either EA or EB. So this is the value. So now here, since our PA is equal to PB, has the value R square and A square. So now putting the value of EA here, 2 times of 1 upon 4/5 naught, and the charge is Q divided by R square A square, and the value of cos theta, can be found from here. Now the cos theta will be here. Cos theta, the value of cos theta. Now cos theta will be taken any triangles, that is OB divided by PB. If I consider the triangles OPB, now OB is A and PB is square root of R square plus A square. If I place this value cos theta here, it becomes A divided by the square root of R square and A square. Now on simplifying, this expression become 2qa divided by R square A square 1/2 becomes 3/2. Just adding the power of this and this will be 3/2. Also we know that dipole moment P, the dipole moment, which is twice A into Q. Now replace this 1 upon 4/5 naught. The charge is 2qa will be P and divided by R square A square raised to the power 3/2. This is our value of the magnitude of the electric field at the point of P due to minus Q and plus Q. Now it's a direction, so obviously dipole moment have the direction from minus Q to plus Q. So this is the direction of dipole moment, and the direction of resultant, which is EB cos theta plus EA cos theta along this one, just opposite of the dipole moment. We can write in the vector format this value. Now therefore in vector format, vector EA 1 upon 4/5 naught minus P vector, because its direction is along PX, R square A square raised to the power 3/2. Now this is the expression of this one. Now this is along px. P is the point where we have calculated the electric field. Now a new case is arising here where this r is very greater a, because a is very small, twice a, which is distance between minus q and plus q is very small. So we have take this in this condition. Now this is the case when r greater a. So we have to remove. Then in that case, a square tends to 0. A square will be very small value. So our electric field will be in the magnitude format 1 upon 4 pi epsilon naught, and this p after a square tends to 0, r square, it become r cube. This is r cube. Now obviously its directions will not change, along will be px, along px. So now this is the value of electric dipole at the equatorial point of the dipole moment. So here two cases we have considered in earlier and this one. So now here electric field due to axial point, twice of the electric field due to at the equatorial point. So equatorial point, now the value comes out here 2 times of 1 upon 4 pi epsilon naught p divided by r cube in this case in the restricted format when r greater a. So now this is a second derivations of electric field due to electric dipoles. Now in third derivations we will consider electric fields due to this dipole at some angle. It means that we will consider at this point. Suppose the point is P making an angle theta with the dipole axis. This will be angle theta. So we will consider in next articles.